Scientists can't explain it. Harvard astrophysicists are stunned. And in just a few weeks, Atlas will pass closer to Earth than ever, revealing whether it's a natural object or something we've never seen before. Hey everyone! For those of you who've been keeping up with the Atlas saga on this channel, things just got even crazier. The object made its perihelion pass on October 29th, and what happened next is beyond anything we expected. We're talking about non-gravitational acceleration, strange trajectory shifts, and observations so weird that even Harvard astrophysicist Avi Loeb is paying close attention. Let's jump straight to the big reveal.
Some of them towards the sun, some of them away from the sun. What surprises me is that they are tightly collimated, and that is surprising because the object is rotating. The last time we checked, it has a rotation period of only 16 hours.
On October 29th, when Atlas reached its closest point to our star, the ALMA observatory detected something alarming. The object was 4 arcseconds away from its predicted location. 4 arcseconds might seem tiny, but in astrophysics, that's a massive deviation. This sort of displacement suggests a force other than our star's gravity was acting on Atlas. And for a supposed comet, that's anything but normal. And that's not all. Observatories like Stereo, SOHO, and GOES-19 recorded an unprecedented event. Atlas brightened in a way no known comet ever has, and its color shifted to a blue brighter than our own star. This marks the 9th confirmed anomaly linked to this mysterious object. But here's the part that could change everything. If Atlas were a natural comet undergoing this level of acceleration, it should have shed at least 15% of its overall mass. That means more than 5 billion tons of material should now be surrounding it in a huge debris cloud. And now, we're heading toward the moment of truth. On December 19th, 2025, just weeks from now, Atlas will approach Earth at its closest distance. If that debris cloud is real, telescopes will detect it. But if nothing is found, then we're looking at a 10th anomaly, an object accelerating without losing mass. And that would break everything we currently know about comet physics. Avi Loeb also noted that Atlas's close pass to the Sun offered a rare chance to analyze gravitational lensing. Our star's gravity slightly bends the light coming from Atlas, and this can reveal clues about the object's true nature. His calculations show a deflection of 0.27 arcseconds, small but clearly measurable. Before we move forward, let's recap the entire Atlas story for anyone new, because this isn't just another minor space update. This could be one of the most significant discoveries humanity has ever encountered. Atlas is only the 3rd confirmed interstellar object, after Oumuamua in 2017 and Comet Borisov in 2019. But Atlas is nothing like them. First, the sheer scale. It is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov. To visualize that, if Oumuamua were the size of a ping pong ball, Atlas would be a multi-story building. And despite its size, it travels even faster than the previous interstellar visitors. The odds of an object being both this large and this fast naturally are under 0.1%. Now, let's walk through the 9 anomalies that set Atlas apart. Atlas follows an utterly baffling path through our solar system. Instead of moving in the same direction as the planets, it's traveling in reverse. Yet somehow, its trajectory is aligned within a razor-thin 5-degree margin of the ecliptic plane. That's like tossing a ball over your shoulder and still landing a perfect shot, something that should almost never happen by chance. And that's only the beginning. In mid-2025, Atlas shocked astronomers by producing a jet that pointed toward the sun instead of away from it. Comets are pushed by solar wind and always form tails directed outward. But Atlas decided to do the opposite, creating a forward-facing anti-tail that completely defies standard comet behavior. Its physical characteristics are just as strange. It is both enormous and unusually fast, the opposite of what we expect in nature, where larger bodies generally move more slowly due to energy constraints. Atlas breaks that rule entirely. Its timing has also raised eyebrows. It arrived in our system at the exact moment needed to pass close to Mars, Venus, and Jupiter, all while slipping perfectly out of Earth's view during its closest approach to the Sunday. The odds of those events lining up so precisely are astonishingly small, almost like hitting multiple bullseyes with different darts thrown at the same time. And when astronomers studied its composition, they found a nickel-to-iron ratio unlike any known natural comet, closer to the ratios we see in engineered metallic alloys here on Earth. Even more unusual is the lack of water. Comets are basically icy dirt balls, yet Atlas contains only about 4% water by mass. That's like discovering an iceberg that is almost entirely rock. Light reflecting from Atlas behaves strangely too. It shows extreme negative polarization, twisting light waves in a way no other comet does, not even Borisov, which we know for sure is natural. Its direction of origin also lines up eerily well with the region where the famous 1977 WOW signal came from within about 9 degrees, which in astronomy is practically the same cosmic street. Near its closest pass to the Sun, Atlas became brighter and bluer than anything expected from known comet materials. That sudden, intense blue flare is extremely difficult to explain naturally and has become one of its defining mysteries. And now, we approach what could be the most dramatic anomaly yet. Based on the non-gravitational acceleration detected by the ALMA observatory, Atlas should have lost over 5 billion tons of material. If that's true, there must be a massive debris cloud around it when it nears Earth in December. If that cloud doesn't appear, we're left with an object accelerating without losing mass, something that simply shouldn't happen in natural comet physics. These strange findings have sparked enormous debate among scientists. Harvard astrophysicist Avi Loeb argues that the scientific community must be open to the possibility that Atlas might not be entirely natural. He isn't jumping to conclusions about aliens, but he insists that when evidence contradicts current theories, researchers must be willing to consider extraordinary explanations. His critics say he's pushing speculation too far, yet he responds that every major scientific breakthrough, from Galileo to Einstein, began with someone questioning the old assumptions. Loeb's approach is straightforward scientific method. Present the evidence, calculate the probabilities, and call for more data. Whether Atlas turns out to be an artificial probe, a technological relic, or simply a brand new category of interstellar object, the implications would be revolutionary. Even a natural explanation would rewrite much of what we thought we understood about objects entering our solar system. The upcoming months will be decisive. December's close pass will reveal whether the expected debris cloud is real or not. If it's missing, we'll be witnessing a historic 10th anomaly, an object that breaks the known rules of physics. Even if we do find the cloud, the remaining anomalies still demand answers. One way or another, Atlas has already changed our understanding of what is possible in the universe. We might be watching a scientific milestone unfold in real time. So what do you think? Is this a bizarre comet, alien engineering, or a completely new class of interstellar traveler? Share your thoughts, and if you want to follow every twist in this unfolding mystery, make sure to subscribe. December is going to be unforgettable.